I would like to welcome Jan Kaplicky to the AA. As probably many of you know, Jan is one of our external examiners and has been for a few years. And I think this is also a good opportunity for the students to see the work of one of the external examiners. Jan has taught at the AA in the past, and his partner Amanda was also a student here. The work of the practice Future Systems is going to be on show at the ICA, I think, beginning April 1st. And so I'm looking forward to seeing some of the more recent projects of the practice. I think one of the things that is, in a sense, very important about the work that the practice does, in some way, and in some way distinguishes them very much from some of the other practices that might be put under the category of high tech, is that they are actually not working in that particular manner. They're not really interested in the engagement with technology in a way that becomes a kind of stylized repetition of what they have done in the past, but rather I think what's important is that in many of their projects they have used technology as one of the components through which they think very inventively about the project of architecture. And I think this is something very, very important, and in a way also something quite unique in terms of their relationship, their attitude towards contemporary aspects of construction. The work of the practice has also, of course, been published internationally, and I think there's a second volume of the book that Martin Pauly did a year or two ago that's going to come out next year. There are, of course, a range of projects, from residential projects to the Earth Center in Doncaster to probably one of the more interesting projects, the Lord's scheme that is currently under construction. And I would like you to join me in welcoming Jan Kaplicky. Thank you.
Thanks. Well, does this work? Yes. This is one of the most difficult tasks of my life, to lecture at AA. It's always enormous lottery if you are in fashion or not. So I assure you we are not fashionable people, which is of course our drama, which they are hated by many magazines and many people. Few schools wouldn't have the lecture. Wrong influences. It's great fun to watch this, how people react to this. There's nothing to worry about. I mean, you might not like it at all, which is fine. But if one of you will bring something out of it, I'm more than delighted. That's enough, or 2 or 3 or whatever. And maybe we can start. It's a lot of slides, so please, can we have a slide? No? It's about 6 slides here. Perfect. Well, this is the world. And the world is looking like this from the satellite, and it looks magnificent. But what is happening on down below on the planet Earth? Next. Next, please. Next. That's what's happening, not that very far away. Only in Romania we are devastating the planet Earth. That's the man here. You know, sometimes you can't believe what you can see here. Next. Or this, the forest in the middle of the Europe and somewhere in Russia. If we don't stop this, That would be a big disaster. Next. And again, we have 30,000 of these people in London and few of them in New York. I appreciate the styles, the lightweight and the heavyweight structures. It is a very sad story. It is something which doesn't feature in architecture or design magazines. It doesn't exist. Nobody ever talks about it, but it exists down the road from here. Next. And if we don't stop this puffing of the carbon oxide every day, that's actually water, but something here is very dangerous indeed. We have to replace it with something slightly better. Next. And from the smallest installation to the largest, it will happen sooner or later, particularly in your lifetime. It must happen. Next. Or the power of the underwater turbine of the wave. Britain is not spending, even on the new government, it's spending virtually zero on these new forms of energy. There are certain exhibitions which shouldn't be mentioned. They don't even deal with the problems of new energies for this island. Next. And vertical windmill generator, horizontal windmill generator, that is all part of the new life. It has to happen, and it will be protested by few fox hunters or something like that, but that's all. They are meaningless. Next. And again, the car will look more like this, and it does look like that, and of course it will take the energy from some source which is clean. It is not polluting car anymore. Next. And from the smallest, even the smaller, it has to happen. There is too much puffing around. Next. And it's remarkable to see what happens in 100 years. So this is sort of 1900, and that's what you see around. I mean, it is complete conversion. You know, maybe in the schools of architecture sometimes this is not emphasized. There are slightly different people living here. Next. And then again, you've seen that around 1900, and I'm sure one of the ladies present will appear very soon in something like that. Next. And telephone almost didn't exist, and now you have more or less something like that. Next. And radio didn't exist, and now it's more like that. Next. Only 100 years, the computer certainly didn't exist. This is pre-1900, but still, nothing like that was available. Next. And choo-choo train looked like that. Now, maybe you are going to work on something like that. It's extraordinary how in 100 years what happened. Again, next. And, you know, a little pedal steamer, now it looks more like this. Next. And the car just existed, and now something like that is developed. Next. And aeroplane didn't exist 1900. Now you can go very soon Mach 3, 4 around the world. Next. And you were sitting comfortably in the office. Now probably it would look more like this. Next. Only in architecture. $1985 and a half, with the blessing of you-know-who, who supported this. And this is 1900. I mean, the inspiration is quite obvious. Next. And I don't know what these people are doing. This is just 2 blocks down from here. They never seen a flower in their lives. They never had a date. They never had a sex. They never had anything. They never drank the bottle of wine. You know, they never drank the drum. I don't know. What do they see if they draw something like that? Next. Or these wonderful people who supplies us with potatoes and tomatoes. I would love to see the face of the guy who designed that next. And you know, fashion is around, and you might like it or not, that's not important, but this is happening in tons of it around. Next. And the parents are doing this busily, the children are doing that in the meantime. I mean, you can't believe it. This is beautiful house for 2004. I mean, that chap has an inspiration there, he has everything. Next. And it all started a long time ago. This is more than 30 years ago, somewhere in Central Europe. First montages and collages and sketches of things long forgotten. Next. And from the small detail to something you might have seen in a magazine, again, long time ago. Next. And from the little flat and this on Trafalgar Square, everybody was rolling with laughter 10 years ago. Now they try and maybe even copy it. Next. And from involvement with NASA and to the little cockpit, I said, what's that? I heard about 17 times. Now we can prove you can do it. This is only 6 meters long. Next. And from Paris Library, which was our great Victorian defeat 8 years ago, you know, the building, 200,000 square meters, the center bridge, libraries, offices. Next. And again, the bridge, people see people reading, compact plan, very small indeed. We couldn't believe when we saw other competitors how small it is. Only 2 cores and the offices on the perimeter. Next. And famous green building now, which is support of our Arabs partners. The first study, this is now almost 8 years ago, of green buildings. Somewhere there, it's basically office building with no air conditioning. Next. And from the first sketch done by engineers, very famous engineers, that from plasticine and piece of pencil to that, it's a straight line of developing. Here you can see everything, the air intake here, just there, you see the 3 legs there, and you see the shape which was dictated by the wind forces around the building. Next. And the cross-section, the floors are obviously blue, and you see the possibility of the circulation of the air in double skin, taking in air. The building is elevated from the ground, so the rest of it is devoted to the people sitting on the ground in the park, and that's the air intake, and it's discharged at the top. Next. And the ground floor totally devoted to people. This is the picture of the little square, 100 square meters just down the road. It was packed. London is totally missing every square meter of grass. Next. And the principle of the building, so the air is taken in, then it circulates through the offices and taken up automatically without any propellers as the velocity increases with the temperature taken out, and the sunlight is transported deep inside the building via a system of mirrors. You can see it in the proper section there. Next. And a couple of basic diagrams from the circulation, the speed of air inside, so it's relatively cool here, calm there on the office floors, the hot temperature at the top and cool down there, so nobody's there. It survives in an average of 22 degrees or less. It is quite a possibility. Next. The detail of the louver arrangements and double skin here, and getting the daylight deep inside the building and can be blocked by the vertical louvers there on the right. Next. And the basic diagram, this is a normal office which peak time is during the summer. The most energy is spent on the air conditioning, on ventilating. The green building actually climbed down the diagram in the middle of the summer. It is 25-30% more efficient. That's good enough at this moment. I'm sure your generation will make it better, maybe 50% more efficient. Next. Another project which is gone now, first photomontage of the tent on the river here. It's a little structure, 30 by 10 meters. Next. And it's completely translucent in a way in the night. You see the membrane, which you can fold it to the about less than 1 cubic meter. The ribs, which are supported by the membrane, in other words, it creates a sort of semi-monoxide structure, and the translucency of it. Next. Can be built in 2 days. The platform is the first day. The second day is the cover comes, and you see the lightness of the structure, the balancing act by the floor, which is the heavy element, otherwise it turns around, obviously. It's so light. Next. And you see it from inside, the system of ribs, which are to attach to the skin, and from outside, the membrane, and completely transparent gable walls. Next. And the skin from outside, the stretching of the handkerchief, and inside the ribs attached. That's that detail, and so, and they are so flimsy they can't stand even on their own. They have to be supported by the fabric itself. Then, next please. And little caravan in Australia. It was done in the great distance in the boatyard. You see the Sydney Opera there. It's an attempt to make some unity between the car design and the caravan. The car design going very fast. The caravan design is basically standing still. Next. No, 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 yes, yes. Oh, God. But you see it here. That's the diagram of the section. You see the 2 beds here in the lower part, the figure standing. There's the kitchen, bathroom, and all this, all that. And it's beautiful body, only 25 millimeter thick, the carbon fiber body, and you are towing only half of the total length of the caravan. Next. This is memorial in Prague for the people who died during the 42 years of communist oppression. It is basically a route from downtown here uptown. It's a public path, and it's 42 steps, 42 years, with the black wall, black glass walls on your side, with all the names of people who died inscribed in the walls. Next. You see it in the detail here, is in direct link between the bridge and the steps. And unfortunate people, they don't even have a place of the rest. They used to throw them in one mass grave. So I think they deserve something like that. Next. And the detail of the axis. You see the steps, you see the people, you see the black walls, the stainless steel steps which can be lit from down below. Next. And detail of the section, so the concrete structure, stainless steel steps, the names, small display cases, again steps here, and the black glass, and the lighting from underneath. Next. And another project from which nobody is interested in, something like that, is the sleeping accommodation for the people who don't have a place where to sleep. It's down on the Charing Cross. It's a hotel. It's a boat, the standard London barge with a few cabins inspired by this Japanese hotel. Next. And you see the layout of the small units. They are much bigger than these submarine compartments where the people spend 3-4 months in a small bunk like this. I mean, it's extraordinary. So for one night in relative comfort is certainly better than freeze in the street. Next. Little trolley, aluminium trolley for a certain restaurant. Next. And champagne bucket, those 3 bottles, the minimal object in the plan. It's a sort of smooth aluminium casting. Next. And the house we designed in Islington, it is from the first model and montage. It's squashed between the pub and existing terrace. It's a terrace only 6 meters wide, and every tree, every branch basically is protected. Next. From the first sketch, when you start to see the accommodation on the 4 levels, the kitchen, the living here, and a couple of bedrooms, you can see it here, and the glass elevation and the front from the glass bricks. And you can see it all here. Next. And from the series of models, the concept here to present that to client, variations on the theme, various shapes. It depends, of course, a lot of it on the money, how much cash you have, or how much things do cost. Next. And then the real thing in between those 2 buildings, you can hardly see it, is protected by the trees, and the aerial view, that's the top bedroom. You see the hierarchy of the spaces. It doesn't have a roof, it has the same glass panel going over the top of the house, and a system of openings. Next. This is the north elevation, that's the glass blocks, and the ramp which is wrapping around the tree here during the night and the day. And of course the tree was protected, and a little bit of gravel here. Next. And the south elevation, that's the whole glass area here, day and night, and a miniature garden here. The same floor finish from sort of little ceramic tiles going through the whole house, every room, including the garden. Everything. This is only 6 meters across. System of blinds going down, and it's very nice to have a rainy day there when the rain runs slowly from the sort of top to bottom, obviously, and producing no noise whatsoever. Next. And this is the opening and the glass elevation from inside, and that's how you clean it from the climbers going over. Next. And that's the main staircase area, which is also protected, fire shaft, so there's a wall behind these units. It is mostly from aluminium. All the staircase is aluminium, all the railing is aluminium, and this is one of the bathroom units for the kids, but there are 4 different type of prefab units which are transported directly in one piece into the house. Next. And this is the kitchen area and the living room here, the dining, and you see the piece of garden here, and again the glass wall sloping to the south. Next. And the main bedroom here and the bathroom, you see the system of cupboards, and that's one inside one of those ports. Next. And the kids' bedroom here, and again entrance to the garden. Next. And aerial view of the garden. It's miniature, as I pointed out, so that's the same tile finish, a little bit of grass and a little bit of trees around. Next. This is another project, wouldn't be very popular here. It's Yokohama Harbor, which we lost gratefully with all the support, and of course it's slightly different than what is the winning scheme. Next. And straightforward inspiration for the terminal building here. Next. And very important, it's actually reverse hull here, direct relationship to the boat. It is same technique how to build it as they build the boats. Next. And this is the project for the Gallery of 21st Century. It's based on the same place where the new Tate Gallery is rebuilding the existing power station. This now seems to be very cheap if you compare it with what's spent on the existing building. It also has direct link, which only after a few years was recognized that it's necessary to the north bank, to the St. Paul, if the link is direct part of the building, and it's basically a gallery of modern art. Next. And from the first sketch model to the plan of the real thing, that's the roof removed here in this model, the garden in front. It's basically suspended roof system of cables, which are far more flexible than system of heavy trusses here. Next. And you see that more happening. They are beginning, beginning to see something which is a part of the roof construction. It's a system of basically cables. It is also a system of hoods, which are letting only the north light to transfer into the building and blocking the south light. So, and the 3 gallery levels here in the drawing and in the model, same thing. Next. And the main entrance via the bridge, it's a so-called ribbon bridge. We had it 3 years before. It's now realized that's the only way how to do it. It's being built, of course, by somebody else. And that's the front elevation, and you start to see the hoods again in the roof of the gallery. Next. And the main section, so the ribbon bridge, the gallery, system of the roof, penetration of the light, and the 3 levels of exhibition and the related spaces in the back, the storage. So you can start to see the unity between the bridge and the gallery. Next. And the system of the exhibition, so you start to see the elements of the roof, system of cables supporting the whole thing. In other words, it doesn't have any structural depth, and system of exhibition walls, which are of course slightly more advanced than some sort of standard system. It's an attempt how to exhibit the modern art. Next. And here is one of the roof elements facing obviously north. So the north light penetrates, it's blocked then by the system of the big louvers underneath. The blue area is the system of solar cells. That's obviously facing the south side of the roof. And you have a system of gutters going around every element in there. And system of air conditioning here, taking in the hot air. Next. And again, system of exhibition, it's more fluid than the normal sort of rigid system of the exhibition spaces inspired by this sort of installation from early 40s. Next. Next, please. And the bridge, which we exhibited here some time ago, but maybe that's the difference between the real thing and the first computer drawing. It's the link between this Stalinist architecture and the things on the other side. It is only floating bridge I know in the civilian use. The reason for it is because we were not allowed to support on both banks here. Next. The bridge is spanning about 80 meters. You can see it from the first sketch already, the pontoons there and the model here. Next. Next, please. And so 80 meters span here, a series of pontoons. You can see it in the section and the plan, the shape of the bridge with the aluminium decking, and it's guided by 4 piles basically. That's only piling system. In other words, the money went in the right place. That's relatively cheap. Normally you would support much more, many more piles, more cost. This was completed on time, on money and budget and all that. Next, please. This is how it is built. So the element, first of all, 30 meter long and 4.5, 5 meters wide, is traveling on the road here with police escort and a lot of sort of activities around it. And then on the water, already attached, you can see pontoons already attached, and obviously the Swiss Navy tug doing the job here. So advantages of the big elements, the prefabrication, doing that somewhere else, are quite obvious here. You are trying desperately to limit the site work. Next. Next, please. It is also openable bridge. The middle part here opens to get the boats through. That's one of the half of it. It's counterbalanced by the dead weight, so it needs very little hydraulic power to actually go up and down. It's very rarely used, but still was one of the requirements. And you see the system of the guidance and pontoons here, and can start to see the aluminium decking and 3 systems of lighting here. Next. And the principal section of the legs, the people, the railing, the stainless steel tube here, and the decking again, light fitting in the handrail of it, and another system of lighting in the floor here. Next, please. Next. That is the decking, which was quite a success. It's about 100 millimeters thick, sort of aluminium planks, about 150 millimeters wide. They are self-supporting. You save quite a lot on the structure. They're supporting these elements. You see the system of lighting, which changes the color as you walk. You see the system of the railing, and massive involvement of the stainless steel cables. Next. And the lonely sort of person on the bridge, and you see the openable part, and obviously the bridge at night with those 3 or 4 lighting systems in action. Next. And more night views, the system of lighting. It's the link between 2 sort of not distant banks there. Next. This is our project, which we already have on the books for some time, but now it's getting the certain speed. It is the Earth Centre in Doncaster, and this is sort of ARC, the main building. It's about 10,000 square meters. It's a part of the park here. It's all built on the devastated land, which the sort of mining activity is gone, and there's absolutely nothing where to go. So this is sort of center of some activity for many people to go there during the day, during the night, and all this, all that. It's basically exhibition hall here. Next. And from the, you start to see the size of it. This is Kew Gardens, about 100 meters across, and that's the latest model of it, which starts to gain all the experience we gain on the research project, like the gallery is involved here. It's all about transfer of the daylight into the building. That roof is very sophisticated arrangement, which I will show you. You can start to see the entrance on the middle level. It's basically exhibition space on the 3 levels. It is, as I said, 100 meters across. It's about 10,000 square meters of exhibition space. Next. And from the form finding of the roof to the more simplistic elements, this is the beginning of it. I mean, the relationship is the eye here. It is the pattern of it. It is the transfer of the light. It is the structure. It is the cover of the certain area. How do you save energy? How do you get light deep inside the building? Next. And you see that again in a model. That's the roof. Here again, as I try to explain, that's the beginning of the exhibition spaces with the system of staircases and escalator. Otherwise, it's a free space for various types of exhibits. Next. And inside and outside, this is what you're going to see. It's also a very colorful object. We try to do that because in that countryside there's absolutely nothing to look at. It's pretty devastated. Even grass hardly grows there. So this is the view you will see from outside, and that's the beginning of the situation inside. Next. And this is the first computer drawings of the roof. You can see these hoods again, which are superform aluminium, and some of them are outside, as you see it, but also same element is inside. So you have a double bounce of the north light penetrating the roof. So the light bounces like that. You, in other words, say it loses intensity. You have more control of it. And in the triangles in between, you have arrangements of the solar cells, which you can, there are separate elements, you can replace them, you can, for the new ones, or if they are too old or inefficient. And the glass membrane is running over the whole area in between additional element of the hoods and the solar cells panels. Next. And then another view of it, so you see the solar cells element here on the surface, that's the top, so the hood transfers the light, and that's the hood at the sort of flip side of it, and the system of the triangulated structure. Next. This is our, I would say, star project. We are all suffering and trying very hard to finish it. It will be finished in August this year, September, August, and it is the media centre for Lord's Cricket Ground. It's quite strange that we were selected, but it's a delightful job. It gives us a lot of opportunities to do certain things which one wouldn't otherwise be able to do. It's basically for the gentlemen of the press downstairs and gentlemen from television and radio to sit down and observe carefully the game of cricket. Next. And these are the photomontages of it. You can see in a heavy architectural competition by Michael Hopkins, that's us here, and then the new stand here by Nick Grimshaw. And it's the camera basically overlooking the game, and that's what it is all about. About 120 people downstairs and about 100 people upstairs, and a bar, of course, on the flip side of it. Next. And from the first ISO, which is marginally obsolete, but still you start to see the rows of the gentlemen of the press, and the bar in the back, and the loose in the middle, and storage, and the bar right in the middle of it, and the model of the cardboard model of the glass wall. And of course it's sloping because you try to protect a certain sort of glare, and coming into the building you have a real problem here because this building is facing directly west. That's the penalty you pay of the best view behind the bowler's arms. That, of course, is very difficult piece of engineering to control it in the critical days of particularly early autumn. Next. And that's principal section. So as I said, rows of the writers, bar in the back, and there's a mezzanine with people for the television. And this is the view of the executive, two executive boxes where obviously a lot of this is going on, and among other things to observe another victory on the grass here. Next. And the plan and the roof plan. So 2 staircases, 2 lifts, the bar in the back, loose, and that's the area of the people writing about the cricket, about, as I said, 120, and there are 2 boxes on each side, entertaining boxes for National Westminster, and the restaurant in the back. It's a semi-monocoque structure. It is probably first completely aluminium building. It's about 85 tons of aluminium. It is also first building with aluminium which is fire protected. It is also so 3 firsts here, but that's not that important as creation of the spaces inside, which we are particularly interested, which are not part of the box system of the rooms which you normally see around you. Next. And the study by Arabs, it's so-called form finding, which is here the stresses or inside the monocoque shell. That is the skin here works. It's not the cladded building. It doesn't have a cladding. It's the skin is part of the structure, and the painful form finding of the shape of the building. Next. And more of the form finding. Minor changes every time. This is about 3rd take of it. Next. The restaurant window in the back, and again this is absolutely smooth finish. It doesn't have, underlined 3 times, doesn't have expansion joints, it doesn't have seams. It's seamless white finish. It's painted. Oh no, I didn't say that. Quiet. And it's exactly what you will see later. It's represented by this model. Next, please. It's a link between the building industry, the heavy, dirty business, and try to do it in the boatyard. It is made in boatyard. The people who have more sense for the precision, they have more sense how to do these things. They do it all the time. They are constructing boats. It's a very difficult link between those 2 industries, link which is relatively unique here. I would like to do more of it, but it's not that easy. Next. And the first elements arriving on the site. So as I said, the skin is part of the structure. This element, which is about 20 meters long, is down there. This is 40 meters across. This is here 4.5 meters. That's the maximum width you can take as a transport. And it's about 6.5 tons here of aluminium. You can start to see the complexity of the job. Next. And we were jokingly doing these little models in the office, but the reality is happening. That's exactly what it is. And that's the element, one of the first one which arrived. Again, 20 meters by 4.5, 6.5 tons of it. You can see the system of skin, the ribs and spars of the elements. So it all works together. That's before the insulation, thermal insulation, and fire installation is installed, but it's already pre-painted. Next. And here, the first installation in Holland, so 1/3 or almost 50% of the building is made in Holland. In another boatyard, it's made in 3 places. Most of it is made here in Cornwall by a firm called Pendennis. It's exactly what's happening here, it's happening there. You start to see the 3 meter, 4.5 meter slices. It's the forming, 3-dimensional forming of the aluminium, and obviously the ribs and spars are underneath. You can see the stitching first, which they do, those little pieces, then they kick them off, and the continuous welding is introduced. Must say I was almost speechless when I thought, first time I've seen this element. This is only 30 meters of it. It will be 10 meters long. The 2 pieces in the middle are missing. Next. And more of it. So you see the scale of the operation, you see the size of the people here, and the provisional stitching, as I said, and you see the plates that are coming from different plates, 3-bender. It's about roughly 6 millimeter of aluminium, which goes up in certain areas to 10 and 12 millimeters in the middle of it. So it is fully aluminium job. It's quite unique in that respect. Next. And again, you start to see the size of it, and you start to see the space inside. This is only 30 meters, it will be 40 meters of that. And again, the ribs and spars with the stiffness which are creating, and the skin which are creating the structure altogether. Next. Another job we are doing right in the middle of it, 50% up. It's a little house in Wales, about 150 meters from the coast. That's the old army barrack which was there, which is now gone. And you see the little eye, glass eye, overlooking the Atlantic here. It was a real problem to get, of course, the planning permission, because you are not allowed to build anything here as a part of the Welsh National Park. Next. And the client owes this piece of triangle of land, and you see that little eye slowly emerging. You see this proportion of it to the sea level there. It is only banks of grass, little bit of grass on the roof, and the glass eye overlooking Atlantic. Next. And the principal arrangement inside the glass wall, the banks on each side. It has the 2 prefabricated bathroom units. This is in the middle of nowhere, so you have to transport these units about 8 meters long on the lorry. You will see that later. And again, the glass elevation here, and a piece of glass in the back, so you have a see-through effect, seating in the middle, a fireplace, and all that, and several bedrooms. There's nothing there. It's a beautiful countryside to really have a feeling that you are spoiling everything. It's only grass, it's only gorse, it's nothing. Every type of architecture is almost interruption of intervention on that beautiful site. Next. And again, the picture and the thing in the plan, so 2 units, the bath and bed together as 1 unit here in the middle of the room, dining space and all this, and that's the glass wall facing Atlantic. Next. And the first unit arrives, so these little numbers are fully equipped with the loos, kitchen equipment, dishwashers, washing machine, and they arrive as 1 piece, as you see it here, directly from London. It's the only way how to get there. You wouldn't be able to build it, and it all has to be designed to be taken by the average lorry. You can't even get a big lorry there. Next. It's another, that was a famous habitable bridge, which maybe you've seen in Royal Academy. It's basically a bridge which has a certain other function than just a crossing in the middle of it. Next. Another thing, we won the competition for the extension of Sir Dennis Lasden School in Paddington, which is that old snake here from 50s, and a series of little pavilions for the 12 classroom, playground, and all that. Next. You see one of the pavilions, there's 2 classrooms together. It has the top-lit classroom, it has glass walls, it has an insulation in the walls. It has basically 1 classroom, second, and the storage wall in the middle, and the system of ventilation at the top. Next. Next, please. Another building for the European Community Research Project. It's here in London on Tottenham Court Road, as you see it here. Right here is the building which has the 2 windmill generators right in the middle of the building. That has basically zero requirement on the energy. Actually, it returns energy during the night. Next. It's a tall building because it devotes, again, the whole area to the people. It has several office floors and a few flats at the top, and has a system of louvers when, again, you have a solar cells, and the main source of energy is the 2 windmill generators. The shape in the plan was dictated by the forces of wind forces, the penetration of wind, so-called Venturi effect, and slowing down on the perimeter of the building, and you increase the velocity of the air and speed of the generator, and more energy is produced. So this went through the several stages in wind tunnel and all this or that. Next, please. And the shape of the building, you see the day factor, in other words, the offices are on the perimeter, the more sort of auxiliary spaces in the middle. That's when the windmill generator is in the middle, lifts and toilets and all this, all that. So that's all dictated by certain sort of engineering forces, the shape and the Venturi effect, the wind going through the middle of it, increased velocity, as I said before. Next. And various tests of the wind blowing through the hole. This is sort of smoke effect. Again, you are testing the shape of the building. This is the final shape. It went through the 3 or 4 different shapes. You are learning all the time. This has a heavy engineering support here on many levels, structural and environmental as well. Next. And another building for same European project. This is a little building in Toulouse in France, and related to the old town, has the same principles of the green buildings, but this is using the heavy weight of the material as to contain the heat of the day, which is released during the night. Next. And the elevation of the building, so heavy ceramic lining of the building, that's the yellow part, and some glazing. So this building works on slightly different prototypes, or a slightly different prototype than the one in London. Next. And the thing in Berlin, that's the third part of the same research project. That's the Friedrichstrasse next to the famous terminal here. It is the low building. It's the height of the normal sort of Berlin building, 21 meters, but it basically gives back to the town large area. It's a greenery. It's a little office building, about 5 floors, and the flats at the top. These yellow towers, of course, are lift towers, and again, piece of land in the middle, back to the people. Next. This building does generate some of the energy, not all of it, but it collects, for example, the grey water in these tanks which are hidden in those banks. This is planned for the time when every building in Germany has to generate a certain amount of energy itself, and basically office plans here. Next. And the principal section, that's the grey water tank, ventilation through the car park. You get the cross ventilation on every floor, and the special tunnel, double wall in the back where the flow of air goes up. So flow of air from the middle of the building up there. Next. And more slides of that. Middle courtyard, almost like a garden, and those banks I tried to describe, and the lift house in the middle. Next. And the school which we nicely lost in Bedford, it's they went for more so-called conventional and building. It's a little private school with about 6 classes. It has a completely translucent roof, so relies entirely on the top-lit classrooms and other spaces. The little windows are only for the view and the external playground. Next. Another house in Cambridge, which is in slow progress, maybe it will never be built. It's a courtyard house with the special aluminium roof, system of rooms around this, and the one big tree which is planted directly as a beginning of the grass and the garden area in the middle of it, and entrance for the car here. Next. And the bus, the electric bus for London, it's a vehicle which has 4 electric motors on the wheels directly. It takes the energy on the final stations. It is the, again, semi-monocoque body of it. It is the bus. slightly different from bus I'm going every day, which leaks, puffs, and smells, and you can't have a conversation. This will be quiet, it will be energy efficient, it will be green, and it will be hopefully a little bit more elegant than the latest product. It is same length, it has far many more people, because the arrangement inside is more easy, because the axles are separated as much as possible. Next. And another house we are doing as a project, that's where we live. That's the conversion in the middle of the London. That's the only picture I have at this moment. Next, please. And that's wrong. That's better. So-called construction tower, which of course we lost competition. That's the movement here between static position. It's the architecture which might be quite interesting for particularly for your generation. It's the mobile, it is moving, it is not static position. It obviously waves with the wind, and it's based on the simple idea of using the aerial idea which you see every day on any car around. Next. And the flower shop, which we just completed, not very far from Portobello Road. It's a glass shield here in front of it, and a series of terraces for the flowers. It's a quite miniature job, but what is interesting, it is addition for the existing house. It's almost like a plugged on the existing elevation. Next. And the terraces of it's full of flowers, and a little bit of canopy, and the projector, and the seating, and more flowers, and it's all nice and white. Next. Well, this is beginning of something to explain. So beautiful structure here, beautiful structure there. You can take the inspiration from all sorts of things. This is hundreds and hundreds years old, and that's about 60 years old, and that's a famous Dakota plane. Inspiration can be taken from all sorts of sources. Next. And again, even the first idea of landing on the moon with a lunar module, and which was conceived with a couple of pieces of balsa with 4 pins, is quite unique. And so don't hesitate to, sometimes the cruel little model can tell other people quite a lot. It tells quite a lot of things to you. But here it changed basically the whole moon program. How do you land on the moon? Next. And yes, something like that, how things are produced, but not anymore. I think we should be looking more to this sort of thing. We don't have a labor, it's too labor intensive, too costly. It's fine for certain old buildings, but it can't replace the needs of the society. Next. And again, I will repeat a couple of slides. It's not individual architects with big names and titles designing buildings. That's a lie. It's a team. You will see more and more of it. There are hundreds of people involved, from the last sort of man or lady making coffee, depends how good the coffee is, on the quality of the product. Here the American sports cars. It's not the architect with T-square, Z-square in a Hollywood pose. That's the past. Next. And production or developing, even the fastest, or not that fast, on stealth aeroplane is made first time in plywood. It's not pressing some mysterious button on the computer. That comes later, or simultaneously. Or this Jaguar car, again, first time it's made in wood. I mean, it's fascinating things to watch, how these things are developed. So, you know, maybe sometimes in school you have same possibilities as these guys, but slightly, of course, less sophisticated versions of this. Next. And then to phenomenal computer programs, which, for example, on something like a Lord's Media Center, we went about 4 or 5 programs. We don't have the sophistication which some boatyard will have or the aeroplane factory has. It is, even the boatyard doesn't have a sophisticated enough machines. They go somewhere else for the special cutting machine. So there is a future, certainly, amazing change here. Next. And whatever I show you obviously is made of, you know, a little bit of glass or aluminium, but some new materials are coming, maybe ceramics, maybe paper. It will change certain sort of attitudes to things. Next. Next, please. And the materials, again, there are no magic materials, but before they spray these things, khaki, they use every other material you can think of, carbon, carbon fiber, GRP, pieces of aluminium, all through things. So it's a complete mishmash at the beginning, which has very good reasons why it is used like that, why the materials are used like that, because the cost of it and the stressage which are coming through the skins of these two machines. Next. And fast evolution, that's 50 years ago, and somebody has the same idea just very recently. That's both stealth, that's in wood, that's in obviously sophisticated materials. Sometimes you are surprised how the good idea is, or the brilliant idea is used again after 50 years. Next. And they were telling people, you know, he will never fly. This is only about 40 years ago, and he will never do that. It's impossible. Well, they are doing it. So don't hesitate to take some silly criticism that this will never happen, you can't do this, you can't do that. These two pictures prove you can if certain people want. Next. And complete change of shape, images, the structure, everything, from this sort of frigate here, which is still going around, to something like that, which by the circumstances which we can't go through the whole spectrum, complete new form of it, dictated by the performances. Next. And one last thing, the one thing I cherish most is a certain democracy in design. You can't keep people, you can't keep students behind some barbed wire and the Berlin Wall. Then they simply take over. Sometimes it takes 40 years, sometimes it's like less. The freedom of design is one of the most important part in your studies, in our work, wherever. It is something which I almost cherish most. Next. Next, please. And they tell you, you can't fly this, or they told these wonderful people, you can't fly this around the world. That's, you know, carbon fiber, two things, two fuselage, and goodness gracious, that would never fly. They spend 6-8 days flying around with this cramming conditions. They've done it. I admire that, because all this criticism you hear every day, every night, and they are told, you can't do this, you can't do that, that's not possible. But they've done it, and that's something one should really watch for people like that. Next. And let's have a coffee. Next. And I kiss you good night. Bye. Thank you. No, I don't know.
You should take some pictures.
Yeah, maybe, but very few.
So maybe there are some questions for Jan after that inspirational and provocative lecture.
There is one question concerning the use of aluminium. emphasized in your lecture that you're doing a lot of green buildings and that it's very important to save energy, but creating or production of aluminium takes a lot of energy. How do you reconcile these two ends?
Well, as you well know, most of the aluminium, about 80% around the world, is second smelting, is reused aluminium, and you need very little energy to produce that. So aluminium is basically very green material. Only bureaucrats in Berlin, they ban the use of aluminium because they don't know better. But aluminium is basically far more efficient because you use less of it than steel. And above that, you don't need to protect aluminium. The pollution created by the old paints, which you have to repeat on the steel, and toxic fumes producing those flames are far more dangerous and less efficient than the basic production of aluminium. Particularly on aluminium is produced by, as you well know, the electricity, which is a clean form of energy during the night, and the second smelting is very, very efficient indeed in terms of energy. So I have no hesitation to.
As long as this production doesn't go into, huge amounts, I think it's all right. And I'm nice.
Well, name me one material which doesn't pollute being made. Well, so you have to build from something, but this is very efficient in terms of weight.
Sun-dried brick.
Bricks are one. Yeah, maybe, but you can't build tall buildings.
One of the things that referring to the question of the circumstances of design, that I think is somehow quite an interesting background to the project. I think in the context of the school, it would be quite interesting if you could just say something about the office and how, for example, the circumstances of the office have to be particular to do these kinds of projects, as opposed to maybe a more conventional office.
I don't think we are very small. As I said, we are 6, 7 people, which some of them are sitting here. I don't think you need certain devotion. I don't think you need some sort of superhuman beings doing this. I think you need only certain understanding, maybe will sometimes, to create some sort of teamwork. Certainly it's more and more other people have functions in office in many ways, but I don't think I consider ourselves very different from others in that respect. Maybe in numbers, yes, but not numbers.
Yeah, I would just.
Is there a microphone you could have?
Hello? Yeah. I just wanted to pick up on Moisen's comments and ask you, you've hinted in your lecture at several times that industrial design, forms of industrial production, ways of advancing production techniques and so on. How have you, can you tell us a little bit about if you have looked at new forms of industrial production, CAM methods, or if you work in teams with other companies perhaps to try and bring in these elements into your work, and if you found that useful?
What do you mean more new production methods? Or
Well, you've spoken, for example, about aircraft production, industrial design, and so on. Whether you just find that as an inspiration, or if you've actually analyzed the way that these things are made, and you found that this helps.
Well, it seems to be I failed completely to explain one building, which is based on that transfer of so-called technology from the boat building to the building production. If I failed that, I'm very bad speaker, and I'm terribly disappointed, because I tried to show that slide of the Wellington boots, and and the deck shoes. That's exactly where the battle is. That is the transfer. That is the tiny bit. You have to choose your targets. You can't do some revolutions. You have a great difficulties even on many levels to do that minor transfer there. So I think if we achieve that, if that building is completed, it will be, we achieve quite a lot. That's enough for me for this year.
I think that point, I think everyone got the point about the transfer from the boat to architecture. I think the question is where might there be alternative forms of collaboration which go beyond, for example, the transfer of one form of technology, for example, from the inspiration to do with automobile production to architecture. This is something that's been there in the history of architecture as part of inspiration for a long time. What now seems, though, more interesting is the way that one can speak about the relationship between one and the other. It's not so much that we can do buildings that are in some way as progressive as automobiles, though that I think is an important part of discussion. But also, what is this relationship between certain architectural ideas and these contemporary technologies of production, because they also in some way affect the way in which we evaluate, for example, the work. I mean, when we discuss some of your projects, the next question would be you're now legitimizing these projects in relation to their progressive condition of technology. But some of them, there might also be, they could be discussed from another point of view.
Yeah.
Every automobile that's designed is simultaneously part of the condition of production, but it also is discussed in terms of its relation to certain situations, conditions of desire. Certain cars are more desirable than other cars.
Yes, but there's also other aspect which I again try to explain, that you're also interested in internal forms, the spaces which are not 8 corners of each room. You are interested in spaces which are, more fluid spaces. You try to crash that barrier, which is not easy either, because obviously, at least at this moment, the floor is flat. Maybe next step the floor is not that flat. Maybe there's something more there. But certainly the walls, certainly the ceiling, all becomes one. There are historical examples. A lot of people try in the past. There's a whole new area which can be exploited. And have you been to space which doesn't have the 8 corners? It's completely different experience. That would interest me. If one succeeds, I don't know. But that's certainly a new task. We try to do it in the Earth Center, where there's a fluidity of the spaces, staircases and all this. That is almost above any inspiration or whatever. It's a reality there. The last one.
One here, one.
How do you consider the lifetime of your designs? With this contemporary needs of design, do you design things to last a certain period of time?
No, because the lifespan of the design depends on very different circumstances than yours. If somebody leaves the building, usually the building goes down the hill and maybe disintegrate. I can't control, and nobody can control that. The lifespan of the buildings are dramatically shortening. The industrial buildings survive 10 years if you're lucky. Shop survives 2-3 years maximum, and maybe some apartments are, flats, even shorter. There's a constant change, but certainly more than some sort of Gothic church, which actually survived without any much changes for 6 centuries or whatever. That is again, even the famous insurers, they accept this. They can insure your building now for the shorter period. Otherwise, they wouldn't insure you if it is not made of, Portland stone or whatever. There are even circumstances like that.
There's one question.
Yeah.
Do you have a microphone? Sir, can you get me? When he speaks.
Hello.
When he speaks.
I must say I was very impressed with the images of the aluminium building, and it struck me.
Is that microphone on, Joe?
Sorry?
Is the microphone on?
Is it working? And well, I remember how many times I've heard mentioned the difficulties of a double curvature of in a surface, and how seldom you see it in architecture, in buildings. And I was wondering what are exactly those difficulties, those technical difficulties, and how did you overcome them with this building?
Are you talking generally about
No, the double curvature in metal surfaces.
Well-
Neil Denari mentioned in 1 week ago in a lecture that the difficulties that it implied and all that. And I was wondering how had you done it?
There's no difficulty with that. It's a technique which is known for a long time, the double bending of a sheet of aluminium or steel, which is normally used in the boat building or shipbuilding. We just use it. That's absolutely nothing new there. To convince people that it's a possibility, like that client or other people around, it's a different story. But the reality is there, it's certainly not a problem at all. It's made it's done in different places than it comes to this country. It is cut by the laser beam or water jet. It's very precision work. It was more difficult a few years ago when there's no computer generated outline of these sheets, things like that. That changed dramatically, yes. So maybe one can use it in that respect. But the steel boats were made for last, they were made, I don't know, 100 years or whatever. The last.
Can you?
You're very preoccupied with the, as the name of your company suggests, so future systems, future materials, and future lifestyles perhaps. I mean, what is the ultimate goal for you? What is the ultimate challenge, that the future has to offer us? And are you going towards that, and is that the goal that you have?
Did you hear the question?
Shall I repeat?
Yes, but quickly.
What is the ultimate challenge of future systems? I mean, are you trying to find the ultimate solution for man's, for the dwelling, the modern dwelling, or with future materials and?
There are no, I didn't mention any future materials, they were not used. I especially pointed that out. So there's nothing unusual in terms. No, I especially pointed that out. I very carefully explained this is all done in absolutely normal materials. It's a question how you use them.
Yeah, but this is where I mean, future materials, it doesn't have to be something of the future. So it can be material that is going to be used in the future.
Speak to the microphone, because then you'll have if you want to have a private conversation, you can have it at the bar.
There's no, I never used the word future material. You're using that. There's no future lifestyle either. I don't preach there's some sort of future life. That certainly is utterly wrong. We are trying to do contemporary modern buildings.
I mean, future systems in itself, and this is where I picked on and started talking about future materials, because it seems that you are preoccupied with future systems.
Well, future systems mean something totally different than what you think. Future systems mean name, which a lot of people can work under. So that's a very important thing. We are not a system of names, but it is the company. You are using the word future materials. I never use that. So you have to deal with that yourself. Because I don't believe there are so-called future materials. And we are not using them.
How about the so-called smart materials that are being developed, that are supposed to be really efficient and, solar?
You have to say what you mean. What is the future material? Because you can have a future material as a concrete. It depends how you use it, what chemicals you put in it.
Okay, but the question was, let's not. I didn't mean to. I mean, if you're saying that you're not using any future materials, then we can just drop this bit of the conversation. The question was, what is the ultimate challenge for you, and whether future systems has a goal which is to do with like the ultimate dwelling or the ultimate way that.
You can't even contemplate to say something ultimate dwelling.
I think maybe somebody else. I think he's trying to answer the question first. Can you pass the mic?
And that's the last one.
Yeah, this is a little bit of the same question in a way, but you're doing not exactly, but you're doing one building at a time. And you're talking about the world's problems, and do you still think that's the best way to do it? You're building one building at a time to solve these other issues. I mean, is it the best environmental way to do one, better building at a time, let's say, than a whole system or a whole idea?
I don't understand the question.
Well, I think it's in a way it's the same question that she's asking. Is there a vision that you have that's more cohesive than just doing one building at a time? I mean, do you see a way to build within cities that has a grander idea behind it than just making one green building at a time?
Well, you have to be realist. You have to think in terms you can handle or you are allowed to handle. You can't have amazing visions of this and that when you are not allowed to even think about it like that. I think you have to, it's enough sometimes to do one building, two buildings, maybe 6, maybe a dozen. Yes, there is a category which you can do some fantastic urban plans, which they will always remain as a piece of work on paper. But that's very important as well. But I think you have to be very clearly distinguish how far you go in your design that is buildable or you can produce it. Because not everything is easy to do. It's jolly difficult to even to achieve what sometimes we try achieve. So I think you have to use it as a salt and pepper in small quantities. What you want to do. You can't have amazingly distant visions where they will never happen. You can do it almost as a second line of defense.
Thank you.
Thank you. No.